Hey guys, thanks for joining, and this time we will be making a rocket ship. This rocket ship hopefully will bring us to the moon and back, and we will be making it by creating this sort of script where we will create various kinds of components and we will be connecting them with wires, and all of those connections will form an algorithm that will create a rocket ship, right? So this tutorial is great for kids, but it also is good for adults, right? If you're an adult and you're a beginner, this time I will be a little bit slower and I will be explaining more details than I usually do. So I think it's really worthwhile for anyone to follow who wants to learn how Rete Editor works. And you see that the script isn't too big, but it contains quite a lot of things that are useful for anyone who's using Rete. So let's get started and let's go and open bitbybit.dev website. And if you want to run Rete Editor, you just hit this apps button. And here we have a Rete editor. So this will open the editor. And as you see, we only have this empty canvas without anything. And we just need to start coding. So the first thing that we will do is we will add a skybox. A skybox creates this background of the sky that you saw in the previous script. And let's do that. Let's go into this Babylon component. Babylon is the game engine that we integrate. And then go to Scene and create a skybox here. So let's click this button. And now you see that on the canvas we have a component. So this component creates a sky. And if you hit the swap canvas button, you will enter a 3D environment. And in this 3D environment, you can rotate by dragging and clicking left mouse button. So this is quite cool, but in this environment, we don't yet have anything that would indicate that we are in 3D, right? So let's change that. Let's go into this draw category here. And now let's hit this draw grid button. And here we have now created a grid on the ground. And if we swap the canvas again and drag and click left mouse button, you will be able to rotate around in this 3D space. So this is quite simple, right? We have now created a sky and the ground. And to go further, we will create a directional light. I will hit right mouse button and I will type draw directional light. And you'll see that I have only one option here, and I will just click this button. And this adds the component to the canvas, which doesn't have any effect on the scene at the moment because, yeah, we don't have any models, right, any geometry, so the light doesn't affect anything. And we just need to change the intensity for now. And also I will change this bias property. I will increase the value a little bit because our model will be quite a bit bigger. So I know that I have to change that. But I will not go into much detail of this property list because, yeah, it's just a bit too much, I think, for the starters. So now we have a directional light. This will create a light and shadows and everything. The scene will look beautiful. But another thing that I want to create is this orange ground that we saw previously. So what I will do, I will just create a circle face. And you see that I typed circle face, and this circle face comes from OCT shapes face create circle face function. So if you want to find it in a menu, you can do that like this. So you go to OCT shapes face, and then you have here primitives, and we have a circle. So I'm just going to click this circle button, and this creates a shape in the 3D environment that looks like a circle, right? So what we can do, we can swap the canvas, go into 3D, look how this geometry looks like. And we can also make it larger by going back to the script and changing this radius. So let's make it 40, and this made a bigger ground. It's red, so that's quite okay. You can also just disable its visibility with this toggle. So you see that it disappeared, and if I enabled it, it appears again. If you click on it, the component, then you see that a 3D object turns green, and this is normal. This is how you can relate objects in 3D with the blocks of code that you are writing. And this is super handy. So another thing that we will do is we will make it invisible, but we will be using this draw command to represent the circle, and this allows us to change its color because we will be able to create some options. So let's do that. Let's create this draw async component, and let's plug the circle output to the entity like that. And also let's use OCT shape simple options. Let's hit that button. And now you see that I have options, which I can plug into this options parameter. And now I can also change the color, right? So I can say, yeah, I want it orange instead of red, or I want it blue. So everything is possible, but let's stay with the orange. I think that fits the model really well. Okay, so now we have created a draw component, OST shape simple options. Let's go further, and now I want to create some points. And to create a point, you can go here and you can create point XYZ. And by the way, of course, vectors are the same as points in bit-by-bit, so they are represented by 3 numbers or 2 numbers if it's XY. But the point that I've created now, it's also visible on the screen. So if you just zoom into the coordinate center like this, you will see a small dot here, which represents the point that we've created. So if I click on this component, you will see that the point also turned green. Also, by the way, if you're watching this tutorial not in 4K, just make sure that you turn on maybe YouTube and just enable the 4K resolution. It will just make it easier to read the text and everything. So okay, so now we have this point, but I actually want to create more points like this. So let's do that. Let's go and let's hit this button to copy the point, and this just clones the component next to it. All of these points were created on the same coordinate, right? It's on 0, 0, 0. So they all are stuck here in this exact same position. And if you change y direction of some of these points, you will begin seeing the difference, right? So I'm just hitting this arrow button on y coordinate, and this increases the value. And also you then see that these points just rise. So, this is the component that represents this point. This is the component that represents this point, etc., etc. So this is quite simple, but on the other hand, it's also good to know how it all works. We need to change these coordinates to 10, 13, and 22. Okay, now that we've done that, these points are quite far from each other. So what I want to do now is I want to create circles on these points. And let's do that. Let's go into OCT category, shapes, wire, and let's create a circle primitive. So let's do this. Let's click this button. And now what we have in our 3D space is the circle. But this time it's just the wire. It doesn't have this inside that is filled as with a face, right? So what we will do, we'll just make it a bit bigger maybe. And I will use these points to create centers for these circles. So let's copy the circles like that. And let's connect all of these points to the center inputs of these circles. And by the way, this is how programming in Rete editor works, right? The point that we've created now becomes the input of the center. And what you will see in 3D space is that all of these circles now just have center positions on these points, and this is quite relevant to understand. In Rete editor, you pass the data from one component to the other through those wires, right? So this is fundamental. And I need to also change these radius values to 5, 8, 6, and 2. And what I'm doing is I'm constructing a sort of framework that will create the geometry for the wings, right? If you didn't really understood that, this is on me. This is usually how we start constructing any type of geometry. We create points, we create wires, and from those we create faces till we reach the point where we can create a solid or something. So this is usually how it all works, right? So what I want to do now, I would like to create a face that joins all of these circles, right? In order to do that, I will use an advanced command from Open Cascade Technology kernel. I will go into the operations and I will click this loft advanced. And you see that this component expects me to provide it shapes, which means that it needs many things. And what we will provide it are all of these circle wires. Before we can provide it to this component, we have to create a list. And lists exist here under the lists category. And what we can do, we can create a list by clicking this button. And now what I will do is I will just connect these components like that all to the elements array. And now I can connect that to the shapes. And you see that I've created this beautiful rounded shape on my screen. And this is not really reminding us the wings that we had, but it's a start, right? I will use this geometry to later on create the wings as well. So let's now go here and also make sure that we have this straight option selected. And also we need to make a solid out of this shape. And now what I want to do next is I want to create a roundings on these corners of the shape. So I will go and I will say that I want to fillet edges. And you see that the fillet is also the command that exists in this OCT category. And what it does, it just takes any kind of shape, any kind of solid, and it tries to round its corners, right? So what I will do is I will just plug this shape in here. I will also make this shape invisible, because if it stays visible, you know, we will not see the effect of rounding. And now it's really hard to see, right? But there's some rounding here happening. What I want to do is I want to increase the radius of the rounding to 2, and this will just make a more beautiful shape, which doesn't have these sharp corners. What we see also here are the circles that we did not hide. And to hide the circles, what we need to do is just, you know, click these toggles on all of the components, and we can also hide those points. We don't really need to see them anymore because we're constructing additional geometry now. So this will serve as a good geometry for the wings. So what I will do next is I will just create additional circle. And this time I will not use the points to connect to the center, because this circle just needs to exist on the coordinate center, and that's the default behavior of a circle. This time the circle radius will be a bit smaller. It's going to be 3. And another thing that I will do is I will create additional list, and this time the list will contain this circle and the last circle. And again, I will use a loft command, and this time I will just hit the right mouse button. I will say loft, and I will click this component. So this one is a bit more straightforward because we only have 2 circles to loft. We don't need to have too many options, and I will just connect it like this. And I will make this into a solid as well. And this time we don't see anything because, yeah, it's hidden by this fillet edges geometry. So let's hide this one. And now you see the shape that we've created. This shape will be used later on, and we don't need to understand very well what it does. Later it will be a bit clearer, but let's go further and let's create additional shapes that we want. I will just make this visible and this invisible. What I want to do is I want to create 2 boxes, one on this side and the other on this side. And I want to cut the shape with those boxes so that only the center remains. In order to do that, I need to construct a few boxes, and I will start by constructing the first one, and we will see how we can mirror it to create the second one. Let's start by going again to this OCT category, shapes, solid, and let's create a box. So with the box is now not visible because, again, this shape hides it. If I just disable it, you will see the box here, and I will make it of 30, and the length, yeah, for now let's also make it 30. And also let's make sure that its origin is not on the center but on the ground. So if we now zoom out of this, you will see how the cube sits on the ground, and that's what we want. And in order to move this box to the side, we will need to do some mathematics, and the length will be somewhat smaller, you know, maybe something like 10, but we will be just doing some mathematics to move this box away, and we will be just changing the length and center dynamically. To do more advanced computations, we need to use mathematics components, and math components can be found here under this 42 category. And here we will be creating a number, and we will be creating a number that is also 10. Let's do that. And also I will just immediately connect it to the length. Nothing changed, right? But now I want to move this box by 5 units to the left or to the right. It doesn't really matter because I will be mirroring later. But let's do that by using mathematics component again, and let's divide a number that we have here by 2. So let's do this, divide by 2. And now we will be adding a little bit extra, right? So let's use the component for adding. And if it's not yet clear, you will see how it works out at the end, but let's just use something like 0.3 here that we add. So now let's construct a point that we did already before. We will just use this number that we get from this add command, and we will plug it to the Z. And by the way, if you want to know what the output of the component is, you can use this preview category and just preview data component. This component can accept all kinds of inputs, and we can just now plug it like this. So you see that by dividing 10 with 2, we get 5, right? By adding 0.3, we probably will have 5.3. And in this way, you can also debug the code. So use this component whenever you don't really understand what is happening, right? Okay, so now we've created this point, and we will use this point to move the box to a new center. So let's do that. And you see now what happened, that it shifted to the right side, and there's a little bit of a gap here. If we want to carve out our wings, we will want to remove the box that we've created from this shape, and we will have 2 boxes which will just carve out the shape for us. This is quite maybe hard yet to imagine, but stay with me and you will see that it's not as difficult as it seems. So let's go further. What I will do is I will also make this box go a little bit lower. So I will just say -1 here. And yeah, we don't see much of a difference, but it just went, and it's now not really on 0, but it just cuts this shape in a better way. So the algorithm will perform better as well, hopefully. Anyway, so now I have this set up, and I want to mirror this box that I've created so that it also comes to the other side. Let's do that. So let's mirror, and I will use this mirror along normal component to do this. So what it takes is the shape. Let's do this. And yeah, that just worked immediately. So other inputs don't need to be added. But what happened is that now you see that we have this small remainder in the middle. And these are 2 boxes that we can carve out. In order to make this all a little bit more clear to you guys, what we just did, we will be cutting out the boxes and the shape that we saw previously, this one, from the filleted shape that we've created here, the rounded shape, right? In order to do that, we will be using a Boolean command from OpenCascade geometry kernel as well, because if you're creating something in OpenCascade, you know, you have to stay with that kernel basically most of the time. Let's do that. Let's go into Booleans now, and we will be creating a difference. So difference is a thing that we're looking for. So the first input for the difference command will be the rounded shape that we have created previously. So let's do that. Let's connect it. And also let's hide it now. Another thing that it expects are the shapes. And we saw that already, right? We had it in the loft. We had shapes and we needed to create a list. So this time is no different. We need to create a list, and I will just say create list. Let's do that. Let's add the loft that we've created before. Let's add the box that we've created and the mirrored box as well into this list. And now I will just organize the script a little, and we will connect everything into the shapes. So now that it's done, it's not really visible what it did because we don't yet see anything, and those boxes are just visible and they need to be hidden. And also this loft is visible. So now let's do that. And you see that now we've created two wings here, right? There are different ways how to approach making the wings differently, and some of you may know better ways. You can start, with the flat face, but actually I think this is quite okay. This time we just needed to create a beautiful looking wings which come from these lofted shapes. This is fine. And this is not really over for the geometry of the wings, because we will need to carve out additional shape of the body into these wings. But when you will be done with that, you will have a precise geometry for the wings that really touches the body in the right way. You already saw previously that we had 4 wings, and in order to have 4 wings, we will just rotate the geometry that we've got now. And let's just hit the right mouse button, rotate. And let's use rotate from OCT geometry kernel. So transforms, rotate. So now we have to also change the axis to vector XYZ. We'll be rotating around Y-axis. And Y-axis, by the way, in Babylon.js in BitByBit is Y-axis, not Z-axis. Now what we have to do is just change this angle to 90. And you will see that now we have 4 wings. Sorry to interrupt. In case you don't know me, I'm Matas, the founder of BitByBit. I hope you enjoyed this video, and if you do, please hit that like button and subscribe to our YouTube channel. I also want to offer you a small deal. Because you're watching this video, I assume that you're using BitByBit platform too. Here's the promo code that will give you a small discount to our silver and gold plans. With these plans, you gain access to our cloud infrastructure, 3D configurators, and other advanced features. Your subscription also helps me develop the content, such as this video that you're watching right now. It also helps me develop BitByBit platform and keep majority of its features free and open source to everyone. Your support means a lot to me. I hope you'll consider the offer, and let's continue with the video. Now that we are done with the wings, or almost done, we will start and construct the body. Okay, so for the body we will also start by creating some points with coordinates. I will make some room for it. I will move the skybox component downwards, and let's go ahead and click point, and let's create 5 points. So we will need 5 points this time, and let's copy paste the same component like this. Okay, yeah, we also need to move this draw grid a little. So all of these points will have to have different coordinates, of course, and let's do that. So the first point will be 0, 10, 0. This one will be 3, 10, 0. This one will be 3, 25, 0. This one will be 0.5, 40. And then this one will be just on 40. So what happened is that we created the profile for the shape that will represent the body, and it's not yet visible. What I will do is I will hide the wings for now because we don't need them. Let's do this. Let's hide all of these components, and these coordinates on these points might look magic to you, but they're not. We will see how we can use them in a bit. But before we go on, it's also very useful to save these scripts to your hard drive from time to time. So don't forget to do the export. Just click this dotted button here and hit export. This will download your script to your downloads folder, and you can open it up later if you forget what you did, if you lose your script or anything. So you can just import it, select that same script, and Rete editor will recreate all of the components from that file. If you are someone who has created an account on BitByBit and you are using our cloud services and you create projects on our cloud storage, that step is not necessary, right? We will be saving your script from time to time to our database, and usually you just have this latest version available to you. But if you are just using our standalone application without being logged in, you did not create a project and the script, then you should remember to just save those files from time to time. And this is also fine, I think. Okay, so let's create a list. Let's connect the middle points to this first list. and you will see why we do it like this in a moment. What I will do is I will create an open cascade wire that is called interpolate points. So you see here that via points we can create quite a few types of wires, and this interpolate wire, it just takes the points and creates a wire through all of those points. So now we have created interpolated wire, and now it's a bit more clear, I think, what we are doing, right? Before we didn't really see it well, but now we do. So we have created point here, and we have created a list that goes through all of these 3 points, right? And then we created interpolated wire between those 3 points. So what we are missing now are the segments like here. So we need to create a line that joins these 2 points and a line that joins these 2 points. Let's do that. I will just use create line wire. So I will find that. I will say create line wire. And I will use this point as a start point and this point as the end point. And in this case, we don't really need to create a list because it just takes 2 points for start and end. And here we will do the same. We will say that we want to create start and end point. And now we have created 3 wires that you see here, and we need to connect them all together. So let's do that. Let's create a list now from all of these wires. Bottom wire, the middle wire, and the top wire. Another thing that we will need to do is we will say combine edges and wires into a wire. This is a long command, but what it does, it just takes all of the wires and combines that into a single wire. We do that because we want to round the corners of this wire, and this will work if we have a single wire that consists of multiple edges. And let's just continue. I will just disable all of these components that we had before, and I will also just hide this component for now. And I will say that I want to round this shape, so I will go into the fillets here, and you see here I have 2D fillets. We're dealing with a wire, so let's use this component and let's provide it this, and let's use the radius of 0.4. So now it's a small difference, but it's important difference. You see that here we have a rounded corner, and on top we also have the rounded corner. So what we will do now, we will use this wire as a framework, right? And we will revolve it around the y-axis. So this is how OpenCascade can construct a shell out of this wire, and let's do that. So let's say that we're looking for revolve command, and you see that it's in the operations. So if you want to find it here, you will click this button, you go to operations, and here you will find revolutions, and here's the revolve. So let's do that. Let's connect this wire to this shape, and that's it. Now we have revolved body of our rocket, right? So while this is quite okay, there are still a few things that we need to do. First of all, we need to use this body and carve out this shape from our wings, because if you will see it now, what happens is that our wings, they're like this. Maybe it's not really clear how it looks like, but we have a body, and we have those wings, but they go into the body, and so we will need to make sure that the body also carves out the wings so that they are exactly touching the surface of the body, right? In order to do that, we will do a few things, but first let's maybe finish building the body with all the windows, okay? That will make it a little bit better, I think, to understand how it all works. So let's now hide these wings. We don't need them yet. We've created now this shell, and what I want to do is I want to cut out the windows, and in order to do that I will just create quite a few cylinders, and I will position them in the right place in 3D, and I will do the same thing that I did with these shapes here. I will just use difference component to cut out the windows. So let's get started. Let's begin and construct those cylinders. And in order to create a cylinder, I will just hit the right mouse button and I will type cylinder. You see that there are many cylinders here to choose from. Make sure that you pick the one that comes from Open Cascade Technology Kernel, OCCT, and I will just hit that. So now we don't see it yet, but it's here on the ground. The cylinder is being created, right? We need to create a vector that will represent the axis. We want the axis to be on Z, like this, so we will use that as a direction. We will say that the height of the cylinder will be, maybe 6 or something. We will use the origin on the center, so like this. Yeah, so 6 will not be enough. Let's make it 10. So what I will do now, I will create 3 numbers. Let's do it like this. So math.number, I will say 22, 25, and 28. And you might notice where I'm going with it. What I will do is I will create a vector xyz, and I will say that I want this to go to y, this to go to y, and this to go to y. So now if you look at the output of this component, you will notice that we end up with 3 vectors. So 0, 22, 0, 0, 25, 0, and 0, 28, 0. And these are the coordinates that we will be using to translate the cylinder into. So let's move the cylinder now. Let's use translate component from Open Cascade Technology Kernel. Let's go into the transforms and let's find on single shape a translation. So where is it? Let's use this one, translate. Okay, this is the right component to use. Let's use this, plug it into the translation, and let's use the cylinder that goes into the shape. And voila, now you see that we have 3 cylinders here. The only thing that we are left to do is cut out the holes in this shape. So let's do it. Let's go here and let's use the difference component like this. What we also need to do is we need to create a list for these shapes. So this is not yet a list. This is important to understand. It's a little bit difficult to explain. As long as you see the shapes represented like this in a single array, this is not yet a list, right? I mean, it is if you consider it to be a pure JavaScript, but basically in bitbybit you need a 2-dimensional array to represent a list. So let's do this like that. So let's create a list. And now I will say that I want to preview the data. And now you see that you have these 2 braces here. And yeah, this will make sure that these 3 cylinders go into this component in the correct format. So let's do it like this. Let's plug it. So I hope this is somewhat clear. If it's not, just go into the Read Editor course on our school, and there I have some videos where you can check out how many-to-many and one-to-one mapping works in bitbybit, and there you will understand better, I think, how this functions. What's the difference between, this kind of setup and this kind of setup. So this is quite important, but here I don't think it makes sense to go into much detail about it. Let's just continue with the video. So let's remove those preview components. And now what I will do is I will use this revolved shape like this, and I will plug it into the difference component. Now if I hide the original body and I hide the translated cylinders, you will see that I end up with these windows. And you will notice that we see through everything here, and this is because what we have created now is a shell, and a shell is not yet a solid. It's also just a collection of faces, and in order to make it into a solid, we'll be using a command called thick. So just look for thick and click this make thick solid simple algorithm. let's connect the output of the difference to this one. And you see that now we have created a really thick shape. We don't need to do it like this. We will just do it like 0.2. That's enough. Now we ended up with some nice looking body, right? We can look into it like this. This is exactly the body that we had previously, right? So this looks okay. And now what I will do is I will hide that cylinder on the ground. So we don't need that. Let's just hide everything here. And another thing that I will do is I will create an offset of this shape because I want to carve out the wings correctly. So currently the wings are still going inside the shape. Let's just see how it looks like. So if we zoom in and go into the middle of the rocket, you see that the remainders of these wings, they're inside the rocket. So this is not good, right? We need to carve out the body, and we also need to carve out the outer part of this body. And the outer part was created by this thicken command, right? That means that somehow we need to create a solid from this object, this revolved object, which is now somewhat, in the middle here. And we need to create a bigger solid and carve it out from those wings. So let's try it. What I will do first, I will transform this shape into a solid. So this is still a shell. We will go here, we will go into the shapes, solid, and here we have this component solid from closed shell. So let's use that one. Let's connect it like this. Now we've created exactly the same geometry, but now it's considered a solid. And now I will be offsetting this shape. So I will go to operations and I will use offset. And we will be increasing the tolerance just a bit like that. And I will be using this shape. And you see that now I've created a shape that matches the outer face of the geometry. And that's why you see this as well. Now two meshes are being drawn onto each other. And this just looks a little bit ugly, but yeah, stay with me, we will be fixing that in a minute. So now I've created an offset of a solid, and I can use this same offset to carve out the wings. So let's do this. Let's just connect this offset to the list of shapes that we've used to cut out all of the wings. And you see what happened now is that if I hide this offset, the windows are now open, right? And also there are no wings anymore inside of the rocket. And you also notice that we have edges that go nicely around the body like this. So this indicates that our geometry is now correct, more or less, right? But we also saw in the previous script that we had is that the body was white. So let's make the body white now as well. Let's go into this thicken part here, and let's say that we want to draw any async. Let's then connect the output of the thicken to the entity. Let's also hide this original body, and now go to the draw command. Again, find this OST shape simple, and let's connect that to the options. Let's make sure that the body is white, and now it looks much better. It's still somewhat metallic. If you want to create rough material, what we can do is we can create this OST shape with material options. So in this case, we will not use that anymore. And we will go into the Babylon, we will go into the material, we will go into PBR metallic roughness, and we will create a PBR material. So PBR means physically based rendering, and this is a concept that I'm not going to go into much detail, but we can just use this material as the face material, right? I can change here the value into white. And also I will say that the roughness of this material is 0.9 and the metallicness is 0.1. And now if I connect this to the options, you will see that the body is much wider than the body before. So this looks quite nice, and let's go and see what else we can improve here. So the shadows are quite beautiful, but you see that they are somewhat, carved here. To increase the shadow resolution, we need to go and find draw directional light component. It's here. And what we will do is we will just increase this shadow generator map size to 3000. And what this will do is it will make the shadows appear more sharp and precise. So this is beautiful. We still see some, geometry like this circle, maybe some points. No points anymore. But in order to hide this one, you will probably need to look for the circle that is still visible. So let's just hide everything that is still visible in this script. Let's do this like that. This is usually what I do when I'm done coding. So just hide all the frame geometry that we used in between the sessions. We did hide everything now, and I think we're finished, right? This rocket looks great. I think it can definitely go into Mars even maybe and bring us back. So I hope this tutorial was useful for you. I hope you now know better how you can use various kinds of components in BitByBit, and also how you code the geometry, how you have to think about making things in BitByBit, how you construct everything. And also what's nice about this approach is that you can change how high your rocket is, for example, by just changing few things here. So let's just create a math.number slider here, like that. I will say that it goes from 40 to maybe 60, right? I will say that the step is 1, and I will put it on, okay, let's keep this on 40, and let's connect this component to y of these points. And now what will happen is that if I change this number, the rocket will change automatically, right? So let's do it. Let's put it on 50. You see that now geometry recomputes, and we've got the higher rocket. So if you want to create few rockets, this is the way to go. You can create, variation in your models. And this is where BitByBit really shines, right? You are not only creating an algorithm that will create a rocket. Now you're building a program that can change your rocket whenever your wishes change, right? So if you want a bigger rocket, wider rocket, you can just expose certain numbers, control those numbers, and everything will adapt. So you did not only create a static model in this case, you created the program for a dynamic model. And this is very important to realize. So I hope you enjoyed this tutorial. I hope you learned quite a few things. And if you did, hit the like and subscribe, right? And I hope you will be watching other videos that I'm making. Cheers!